Yes, sir. Good afternoon to all. On behalf of CIT ACM Student Chapter, I would like to invite Dr. Aswani Kumar, Professor, School of Information Technology and Engineering, VIT, for the online seminar on exploring blockchain technology. He has completed PhD degree in computer science from VIT. His research interests are information security, machine learning, and quantum computing. He has published more than 100 research papers in various national, international journals and conferences. He received Youngest Scientist Fellowship from Tamil Nadu State Council for Science and Technology for his research at TIFR Bombay during the year 2004. He also received the New Indian Express Award for inspiring young teachers. He has executed few research projects funded by Department of Science and Technology, Department of Atomic Energy, MHRD. He is a senior member of ACM and organized various summer school programs in association with ACM. Once again, I welcome you, sir, for this online seminar. Yes, sir. Thank you, sir. Yes, Dais is yours, sir.
Thank you, madam. Thank you very much.
Yes.
So,
yes.
My slides are visible now, madam.
Yes. Yes, sir.
Okay. So, very good afternoon to one and all. I would like to thank madam for inviting me, Sangeeta madam, for inviting me to this invited talk on blockchain technology. This particular program is arranged with the help of ACM. I think all of you are aware that ACM is the premier global community for especially meant for computing professionals and students. We have about 1 lakh members spread across 170 countries, and we are interacting with 2 million computing professionals across the globe. So we have a clear-cut mission and vision, and I'm happy and proud to be an ACM member. I invite all the student community. I understand that we have students now from BTech Computer Science Engineering program and BTech IT program and other students. So they can be part of ACM and gain immense benefit out of this large computing body. And this particular talk is sponsored with the help of ACM under the Distinguished Speakers Program. So today we are going to deal with blockchain technology, and my session, in this session, I will be giving a brief introduction about why we need to go for blockchain, what is the use, what are the benefits, and first of all, when to go for blockchain. So then I will be talking about blockchain fundamentals, what are meant by what is a block, how a block is created, what a block contains, and what are the properties of the blockchain. And also I deal with certain cryptographic primitives, what are all fundamentals to the blockchain. So there are a few crypto primitives which are fundamental to the blockchain, and also how the blockchain operates. So that means the functionality of a blockchain. This also we discussed today. Then I will be dealing with few applications, mentioning where all the blockchains are applied. Then also we deal with what is the scope of growth. So how is the growth of blockchain, and I will give some references so that those who are really interested to pursue their further studies in this exciting area, they can refer that. So these topics would be covered in the current session. Now, all of us, we are all in the computing profession, either as a student or as a faculty or as a professionals. Among all the disciplines and domains, computer science and information technology is the youngest one. Whether it is chemistry, if you take physics, whether it is biology, all other subjects, when you compare, computer science is a relatively young discipline which has about 100 years of almost 100 years of age. Among this entire age of computer science, if you divide, there is an age called mainframe age. Then there is an age called personal computers age in the years 1980s. Then there is an era called internet era, wherein which post 1990s, internet has revolutionized the computer science discipline. Then in 2000s, whatever people have witnessed is social media boom. All of us are engaged with social and mobile devices and also communications. Subsequently, after 2010, there is another paradigm called blockchain, which is actually creating a massive, tremendous impact on various applications and various sectors. That is the discussion point today. And of course, subsequently, there are other emerging areas. So this is the broader spectrum of computer discipline. Now, if you see how the data is getting generated, so data generation per minute, if you notice, these are the statistics. I'm talking about per minute. In 2013, per minute, Google was processing around 2 million Google queries. Whereas now, per minute, Google is processing 5.9 million queries across the globe. Similarly, if you notice YouTube, in 2013, there are about videos containing about 48 hours watch hours videos were uploaded per minute. Whereas now per minute across the globe, YouTube is receiving 500 hours videos. So that means in a 1 minute, number of videos that are uploaded, if you want to view, it is about 500 hours. So you can see the massive amount of data that is getting generated and also getting uploaded. Okay. Similarly, Instagram, Twitter, Facebook, emails, that whatever we are seeing, we are sending. If you notice, there is no much difference, significant difference in the emails that are sent between 2013 and 22. But whereas when you look at all other social media related data, it is massively increasing. Now the point is, this is only just statistics about the social media data. Is it that data is getting increased only in the social media? Not only there, everywhere data is getting generated, that too in a digital means. Now we are all taking photos. You go to a healthcare sector like hospitals, there the patient records are digitized. Now the customer bills are digitized. Everywhere digitalization is creating massive amounts of data. So this particular slide just gives you a brief details of how data is getting generated. But the question is, when this such large amount of data is getting produced, there are certain clear strategies that needs to be evolved. This is about what is the type of data we have and what we don't have. Similarly, what type of data we need and where to get it. So how to structure that particular data? How do I am going to structure it so that I can store, I can process, I can analyze? So how do I going to structure it? And above all that, yes, I have the data, but how I am going to make use of that data, right? And when I say use of the data, ultimately it should add value, right? So when I keep the data, what is that I'm going to create value? I'm taking every day multiple selfies. What is that I'm taking, adding a value? So these are all the important things which we need to look at. And above all that, the necessary infrastructure do we have to deal with the data and secure the data? This is the another fundamental challenge. How we are going to deal with the data and also secure the data. So these are all the some of the important points that we need to think about. I'm creating the data. Yes, when I go to healthcare industry like hospitals, pharmacy, the data is getting generated. The user's data is there. Whether my data is having privacy requirements met or not. Similarly, whether my data is not tampered, I am making online transactions. Integrity of these transactions are maintained or not. So all these things have to be checked, or how all these things need to be verified. Now, in this particular backdrop, you have a technology called blockchain technology, wherein which you are having security, number one. Number two, there is no single point of failure. So that means, imagine all the data, I'm going to keep it in a centralized database. Imagine if the database centralized server gets failed, whether I'm going to have the availability of the data or not. So that's a big question. So in that regard, blockchain provides no single point of failure. Similarly, the transparency, and above all that, there is no third party involvement. So there is no third party involvement. Real-time tracking of the data, reducing the cost, so trusting the transactions. First of all, there is a transaction that has happened, whether I can trust the transaction or not. So all these things can be met or can be realized with the help of blockchain technology. So now the point is, what is a blockchain technology? There are various ways with which we can understand the blockchain technology, but just to provide an introduction, an informal way of, remember it is an informal way of introducing the blockchain is, number one, blockchain is a distributed digital ledger. So this is one thing that you need to understand. The second one is it is cryptographically signed. So distributed digital ledger, which is cryptographically signed. We know what is manually signed. You know, we do all our signatures. We are talking about cryptographically signed. And all these cryptographically signed transactions, all these transactions are grouped into blocks. So distributed digital ledger, cryptographically signed transactions that are grouped into blocks. And there is one more thing, these are all worked with decentralized nodes. So you need to remember these important things. Number one, distributed digital ledger. Number two, cryptographically signed transactions. Number three, certain number of transactions, like say 10 transactions, 15 transactions, or 20 transactions, or 5 transactions. Set of transactions grouped into blocks, and these blocks are maintained and managed by decentralized nodes. So these four things, if you remember, that is nothing but blockchain technology. Number one, distributed digital ledger technology. Number two, cryptographically signed transactions. Number three, all the signed transactions grouped into multiple number of blocks. All the blocks are maintained by decentralized nodes. Right? So these 4 points, if you remember, that is nothing but the blockchain technology. Now, if you further go, each block, when I say a group of transactions, all these blocks are, another thing is cryptographically linked. That means one block is linked with another block. So all the blocks are linked together. That is why you are having a chain. So it is not that we are dealing with independent blocks, rather all these blocks are chained together. So that's why you are having blockchain. Okay, how these chains are created? With the help of a common decision called consensus decision, taken by the decentralized nodes, Okay. So far what we have understood? We have understood that it is a distributed ledger. When I say ledger, you can think it, for now you can think it as a database. So distributed ledger, they are all having cryptographically signed transactions. So transaction 1, and transaction 2, transaction 3, like that, multiple transactions. Each transaction is signed. How it is signed? Cryptographically signed. Multiple transactions are grouped into blocks, and the blocks are cryptographically linked. So that forms the chain. And all these blocks, once they are cryptographically linked, they are maintained by the decentralized nodes. So this is blockchain technology. Remember, once you create the block with grouping some set of transactions, remember the blocks are not possible to modify. That is why you call that blockchain as immutable. Okay, you can't tamper. That's where your trust is coming. So since you are not able to modify the transaction, you can always trust it. Imagine that somebody is sending some online transfer of money. Okay, how do I trust it? If I know that if my transaction is not tampered, obviously I will trust it. So that's why, since blocks are difficult to modify, are not able to change, they are immutable. So blockchain is immutable. Remember, the blockchain, once you create the blocks, every cryptographically signed transactions. Madam, are you able to hear me?
Yes, sir. Yes, sir.
Is that audible?
Yes, sir. Audible.
Okay, okay. So number two, it is signed transactions. Couple of transactions are grouped into blocks, and the blocks are cryptographically linked, creating a chain, and the chains are maintained by the decentralized nodes. So this is the blockchain, very broad understanding. Now the question is, sir, after all, we are going to maintain the transaction. Why not I deal with the database? I have a database, have multiple able to store my transactions. So I have an RDBMS where in which I can keep the transactions. Why I have to go for a blockchain? Now, if you notice, this particular image gives you a clear understanding of the difference between the blockchain and the database. Typically, the databases are centralized in nature, whereas blockchain is decentralized. Architecture-wise, if you notice, databases are client-server model, whereas blockchain is peer-to-peer model. If you look at the performance-wise, databases are quite fast, whereas the blockchains are relatively slow because you have to group certain transactions, then you have to create a block. So all this takes time. Similarly, maintaining the databases is cheap, whereas the blockchain is costly. But the most important thing is that transparency, data integrity, cryptography. If you notice, these are all the features of blockchain the database do not have. Now, let us see how it works. Now, imagine this is one particular node. Okay, I said there are multiple nodes in a network, but let us take one particular node. That particular node is trying to make a transaction. Okay, so it is requesting a transaction. Now, what happens? So, if you notice, that particular requested transaction would be broadcasted to different nodes. So, this is a one node, this is another node, this is another node, this is another node, right? So it sends the transaction sends to multiple nodes asking for, hey, look, there is a transaction. Do you have any objection or do you want to validate it? If the nodes, once the nodes are validated, then that particular transaction gets added. When we have certain set of transactions, the transactions gets added to the block. So a verified transaction would get added to the block. Once you have a block, that block would be getting added to the blockchain. Okay, so you have a node creating a transaction, transaction gets verification. Once verified transaction gets added to the block, when once a block is created, block is added to the blockchain. So transaction, transaction verification, once it is verified, adding to a block, and block is adding to the chain. So then you say that entire transaction is completed. So as I said, once you create a block, whatever the transaction that is added, whatever the block that is created, it is immutable. So that means you can't tamper it. So this is a very broad understanding of transaction verification, adding it to the block, block getting added to the chain, so completing the whole process. As I said, there are a couple of benefits like accurate tracking, it's a permanent ledger, all that. Okay, where are all the potential applications? There are several potential applications of blockchain, including in automotive, financial services. There are certain countries which have brought in the blockchain for voting applications. So in fact, if anybody wants to vote, what we are doing is we are going to a location where vote is collected. Now, with the help of blockchain, what we can do, we can remotely vote to whomsoever is the candidate we wanted to elect, and that particular vote is regarded as a transaction. So your casting of vote is verified, and once it is validated, only it gets added to the block. Once it is added, no one can tamper it. The same philosophy of voting also, right? So digital blockchain technology is being used in certain countries for voting scenarios and as well as healthcare. Now, if you look at the network-wise architecture, your blockchain network sits on top of your typical layered network architecture. So you can notice that you have typical TCP/IP layered architecture of application layer, transport layer, and physical layer, the 5-layered architecture. It sits on top of that. So the node A, node B, node C, they're all interacting over blockchain network. So when actually the blockchain evaluation started, it is though people have realized the importance and potential of it after 2010 and 2012 and all, but the roots of blockchain started with 1990s itself. Now you have cryptography. Those who have already studied cryptography and the network security course, you must have studied blockchaining principle. Okay, so where in which the data is getting created as the form of blocks and it is getting processed with the help of blockchaining principle. Ciphers are created with the help of blockchaining principle. So the philosophy of blockchain as such is already there in the literature from the early 90s itself. And this data structure, introduction of a new data structure called Merkle tree in 1992, this is the backbone of the blockchain what today we are witnessing. So Merkle tree is the data structure which is the backbone of blockchains. And then in 2008, Bitcoin, which is the cryptocurrency, was introduced with the help of blockchain. So typically people think cryptocurrency and all that, but actually if you notice, that has the root from blockchain. Okay, so after that you can see that now blockchain evolution has evolved significantly. So that means if you really wanted to understand the principles working functionality of blockchain, you need to understand the crypto primitives and also the data structure. So to understand blockchain, you need to know the linked list of the data structures, trees, similarly networking principles, similarly cryptographic primitives, which includes hashing, public key technology, public key security, cryptography, digital signatures, and finally what is meant by ledgers. So once you understand these things, understanding blockchain is very, very easy. So you need to know certain data structures fundamentals, networking fundamentals, cryptography fundamentals. With that, you can master blockchain. So I'll quickly give 2-3 slides about what are the cryptography primitives that are used by the blockchain. Number one, it is the hash function. So hashes are one-way functions which are rooted into the cryptography. It is mainly meant for any hash function. If you notice, it takes a variable length input, and produces a fixed length output. Okay, so the point is that it is one-way function in the sense creation of the hash value. That means fixed length output value is easy when you have a message. Okay, taking the message, creating the hash value is easy, but it is not two-way in the sense if you have a hash value, creating the original message of hash is relatively impossible. Okay, so that is the requirements of any hash functions. So as I said, it is one way, and the functions, especially hash functions, are collision resistance. Okay, so cryptography has several hash algorithms, which include secure hash algorithm with 256 bits, 512 bits. So if you notice, the whatever the output of any hash algorithm, we also call that as digest, because it is taking a variable length input, creating a fixed length, a small length output, and hence we call the output as hash algorithm as a digest also. So I don't deal with details of hash functions. So we understood hash is a one-way function, number one. Number two, it takes variable length input, produces a fixed length output. The output that it produces is called digest. And also, another important thing we notice is that having an input of variable length and producing a fixed length output is computationally easy, whereas taking an output and trying to create the message out of it is impossible. That's what is the requirements and key characteristics of hash functions. Another important cryptographic primitive that is behind the blockchain is the asymmetric key crypto technology, wherein which we actually, when it comes to cryptography, we have two types of ciphers. One is called symmetric ciphers, another one is called asymmetric ciphers. Symmetric ciphers, in the sense, they take the same key for encryption and the same key they use for decryption purpose. So encryption and decryption are done with the help of same key, and they are called symmetric encryption. You have popular algorithms such as DES, AES as examples for symmetric encryption algorithm. Of course, we don't deal much in the blockchain for the symmetric. What we deal here in blockchain is the asymmetric encryption. If you notice in the asymmetric encryption, you have going to deal with two keys. So one key for encryption purpose, another key for decryption purpose. Since you are using two keys, it is called asymmetric encryption. Okay, so if you notice, generally public key is used for encryption purpose. One key, that is the private key, is used for the decryption purpose. So those who have already undergone the cryptography, it is easy for you to quickly understand. But those who have not undergone cryptography, it takes a time for you guys to understand. So imagine if two people are communicating. Okay, I think I have a next slide on this. So imagine Bob and Alice are interacting with each other. When Bob is sending a message to Alice, what Bob will do, Bob will take the message, whatever he wanted to send, he encrypts that message with the help of Alice public key. That means, remember, Bob will have one public key and Bob will have his private key. Similarly, Alice also will have her public key. Alice also will have a private key. So that means there is a key pair. Bob will have a key pair. Alice will have a key pair. So while sending a message, what Bob is doing, Bob is encrypting the message with the help of public key of Alice. Remember, since it is a public key, Alice's public key would be known not only to Bob, to everybody. So what Bob did, Bob picked the public key of Alice, encrypted the message and sent it to Alice. Now what Alice is going to do, Alice is going to decrypt that message with her private key. Okay, since what Alice is using is the private key of Alice, only Alice would know, no one else would know. Even if somebody wants to decrypt this message, it is impossible, because the decryption is possible only with the help of private key of Alice. So this is the public key technology. If you have understood, fine. If you have not understood, that's okay, no problem, don't worry. But the point is that you need to understand it is called asymmetric key cryptography, wherein which we use two keys. Remember, Bob is the sender, Alice is the receiver. So encryption has happened with the help of receiver's public key, and decryption has happened with receiver's private key. Okay, so if you understand this, that is fine. Okay, you just remember this concept. So it's a asymmetric key cryptography, and this is the another key concept behind your blockchain. Okay, now if you notice, there is another way of doing this. Alice is sending a message. What we discussed is Bob is sending a message to Alice. Now imagine Alice is sending a message. Alice is sending a message to Bob. This is very important difference you need to understand. Now, while doing the signature, what Alice did, Alice took the message. She signed that message with the help of her private key. So that means sender's private key. So please remember, if receiver's public key is used, it is encryption. If sender's private key is used, it is signature. Okay. So now you see the message gets processed with the help of Alice's private key. That means the sender's private key. That message is sent to the Bob. Now what Bob would do? Bob would process that message with the help of sender's public key. Now see here, this is on the other side. For the decryption purpose, it is processed with the help of receiver's private key. For signature purpose, it is processed here with the help of sender's public key. So the difference you guys need to understand. So this is called encryption and decryption. This is called signature and verification. So encryption and decryption happens with the receiver's public key and private key. Signature and verification happens with sender's private key and sender's public key. This concept you guys need to remember it, because what we are going to do is signature. I hope couple of slides back we said that transactions are digitally signed. I hope you guys remember, in the few slides back I have mentioned that transactions are digitally signed. So what do you mean by digitally signed is that this is what is digitally signed. Okay, so the transaction is signed with the help of sender's private key. Transaction is verified with the help of sender's public key. Remember, when it comes to verification, anybody can verify. Okay, not only Bob, even some John can verify, because verification can happen with the help of sender's public key. Since it is to be verified with the help of public key, anybody can verify. That's the beauty of digital signatures, and that's the reason why we call it as transparent. Anybody can verify it. Okay? Since anybody can verify it, what obviously happen is your trust gets improved. I hope you guys are able to follow. Madam, is it audible?
Yes, sir. Audible.
Yes, sir. Audible.
Yes. So this is about the concepts behind it. Okay. So I'll just quickly, whatever I've explained is there in this diagrams. So again, the same concept. Private keys are used to digitally sign. Public keys are used to verify purpose. These are what is about this one. So these cryptographic primitives, number one, hash algorithms. That means you are going to create the hash of it. Means take a variable length output, get a fixed length, take a variable length input, get a fixed length output is the hash, and it's one way, and the other one is asymmetric cryptography. Now let us come back to the blockchains. So that concepts you please remember it. Now we keep on saying that transaction. What is a transaction? A transaction is anything. It is like recording of transfer of assets. Like you can imagine that I'm sending some money to some X. So it's a transaction, right? So you can think about an example transaction which is given here, input from some account to some other account, the amount that has to be transferred. So you can think that as this one. So each block in the blockchain contains multiple transactions, right? So you can see that we are verifying the validity of the transactions. That is very, very important. Few slide back I talked about verification happens with the help of digital signatures. So transactions are signed and can be verified. So when I'm saying that I'm sending some money to some X, I'm signing the transaction. Then anybody can verify this transaction later. Okay? So with the help of public-private key pairs. Now, so we have talked about a transaction. Transaction signature also we talked about. Now, what is meant by ledger? Ledger is a collection of transactions. We all see in the banks maintain the ledgers. So a collection of transactions. Now the ledgers are stored digitally, and remember they are large databases, and so far they are maintained centrally. So that's the reason why we are talking about single point of failure happens, it's a big problem. So that's why we are going for distributed ledgers. So centralized ledgers have several problems that you also know about it, or you can read about it. So the point is that we are going for distributed ledger. So a distributed ledger is implemented using the help of so this is the distributed ledger. So ledger is distributed, right? So each node is maintaining the ledger. You see here, the ledger has transactions, transaction 1, transaction 2, transaction 3. So every node has the same ledger now. Now imagine the ledger can have a new transactions, right? Whenever there is a new transaction, the transaction gets in. So take an example here. This particular node has a new transaction, transaction 4. Now this transaction comes in. So this particular transaction information that get updated to all other nodes. So see here. So the transaction 4, the details of the transaction 4 is being distributed, informed to all other nodes. So every node can verify this particular transaction. We said how to verify the transaction, right? So every node would verify the transaction and say that yes, the transaction is fine. Transaction is verified. Once if the transaction is verified, transaction 4 gets added to the ledger. So the other node also should be getting updated. It would get updated in the meantime. So once a transaction like this are getting pooled, so a pool of transactions should be created with the help of a block. We will come to that later. So the point is that we have understood that there is whenever there is a transaction that happens at a particular node, that particular node will inform the transaction to the remaining nodes. So remember that every transaction validity is verified and ensured. How it is verified and ensured? As we said, by verifying the digital signatures with the help of digital signatures, right? So now the point is that when you have set of transactions, all these transactions are pooled and made it in the form of a block. Okay, all the transactions get into pool and made it into the form of a block. So remember, when once you have a block, it is not that you store that block is getting hashed. Now this is where your whatever that hashes we discussed that comes. So when you do any hash, what you get is the digest. So remember, this is a variable length input, digest is fixed length output. So you get a fixed length output. So you can create any number of transactions with that help of any number of transactions. You can create a block. Once that is done, you are going to create a digest out of it, right? So now this is how a block typically comes. So what a block contains? Block contains the block number. Block contains the block. Block contains the block number, and there are other fields such as block hash value, previous block hash value, Merkle tree root hash, timestamp, size of the block. These are all the details of the block. Now you see here, these are all contents of the block. So this is what a block looks like. We will understand what are all these things. So you can see that there are certain transactions, and you can also see that hash of the transactions is also there. So that means when you have suppose a new variable number of transactions, hash of the transaction is created. Once you create the hash of transaction, remember you can't change it, because as we have discussed, changing the hash value requires to change the transactions. But you have the verification that is there. It is not possible knowing the hash value what are all the transactions that are happening, right? So now the point is, what is this hash of the transactions and What is the hash root? Let us understand. So we need to understand hash of the transactions and hash root. So these things we need to understand. And for that purpose, we need to understand a data structure called Merkle tree. So you can see a Merkle tree structure looks like this. The bottom of the structure, bottom of the tree structure contains the transactions. Of course, here it is given as data 0, data 1, data 2, data 3. You can think them as transaction 1, transaction 2, transaction 3, and also transaction 4. Imagine you have 4 transactions. Now, the bottom nodes are transactions. What happens? You take every transaction and create a hash of it. Hash of transaction 1 is this one. So hash of and transaction 2, hash of transaction 3, hash of transaction 4. Then what happens? You take this hash 1, this is hash 2, and put together, create a new hash. So hash 0, hash 1 is the new hash, which is hash 4. Okay. Now hash of these two hashes is another hash. Finally, hash of these two hashes is the root hash. Okay, so the root node is the root hash. This is what is there in your block structure. So at the bottom of the tree structure, you have transactions. At the root of it is hash of hashes. You can think it as hash of hashes, because transaction its hash, transaction its hash, transaction and its hash, and these hashes are created with the help of algorithm called secure hash algorithm. Typically you have 256, and of course we have even sharp 512 algorithm, using which you take a transaction and create a hash of it. Okay, and remember, once you know hash, what are the transactions, it is not possible to know. But if you have the transactions, creating the hash is simple, but from hash going downwards is impossible. Okay, that is where your immutability comes. Okay, so the bottom row tree contains the transactions. The Merkle root is stored within the block header. So now you can see that this hash of the hashes is stored in the block structure. Okay, so that means this block contains these transactions, these 4 transactions this particular block contains. Similarly, look at its previous block. Probably this block may be having 4 transactions, 10 transactions, or we do not know. So this is its previous block, and this is its next block. So this is its next block. This is the previous block. Okay. So previous block has a couple of transactions, next block will have a couple of transactions. Now, where is this chain is coming into picture? The chain is coming into picture because you see here the block structure is pointing to the previous block. So see here, hash of block 0. So imagine this is block 01, this is block 02, this is block 03. See here, hash of block 01. So that means it is pointing to this. Similarly, you see this one, hash of block 02. This is pointing to this. That means 03 is pointing to the 02. So that is how your connection is coming, or chaining is coming. You can think it as a chain. So blocks and connected with the help of the previous block hashes. So if you see every block header, previous block hash, and timestamp at which this particular block is created, nonce, which is a random value that we will see later. Merkle root hash. What is this Merkle root hash? The Merkle root hash will contain all the transactions and their hashes. So see here, these are all the transactions, transaction 1 to 4, and hash of it is the Merkle root hash. So this is called Merkle tree, and hash, the root node contains the root hash. I hope So far you understood this particular tree structure, you understood the blocks, you understood the way they are getting chained. Okay, so blocks are chained together through each block containing hash of the previous block header, thus forming the blockchain. Okay, now point is how they gets implemented, how the blocks are getting created. Who creates the block? You said node 0, node 1, node 3, node 4. Who creates this block in the, say, suppose I have 10 nodes. Who creates the block? Creation of the blocks happens with the help of consensus among the nodes that are there. So all of them, they should agree, but at least the majority of them should agree for the creation of the block. So that's how the blocks are created. Imagine if invalid blocks are created, they will be detected and rejected. Okay, when you call it as invalid block, provided you have an invalid transaction. You remember, you are actually verifying transactions in through digital signatures, right? And how the blocks are created is with the help of consensus, and for that you have separate algorithms called proof of work, proof of stake. One algorithm or one particular way of creation of block we will see. Okay, so consensus we will see how when you have multiple blocks, when multiple nodes are participating in creation of the blocks, how the blocks would be created. One of the typical way is called proof of work. Okay, so when imagine there are multiple nodes, right? Node 1, node 2, node 3, node 4. These are all creating the blocks. When multiple nodes are creating the blocks, you know, whether this node also can create the block, this node also can create the block, this one can create, or this one also create. When they are creating the blocks, remember, the nodes will get a reward in the form of cryptocurrency and other means. The point is that when they create a block, on what basis they create a block is through one of the algorithm, consensus algorithm called proof of work. That means they should say, hey, look, I did some work. Either every node will say, will do some work, and the node which do that particular work in the race, that particular race, or that one by doing that particular work is allowed to create that particular block. Now let us see what is that work. Work here is solving a particular puzzle. So work is nothing but solving a particular puzzle. What is the puzzle? Let us think that, imagine the puzzle is any node which is participating in creating the block should find a hash value. What is the hash value? For what I should find the hash value? You should find a hash value for the input. The hash value should start with 6 zeros. You should find such hash value. And remember, the input is the text, which is the blockchain, and also nonce, which is the random number. Okay. Now the question is, what is unknown here? Unknown part, if you notice, blockchain text is common to everybody. What you are supposed to get the output, the 6 zeros as the initial hash value, that is also known. What is unknown is the nonce, the random number. So finding this random number is the puzzle. Finding this particular random number or nonce is the puzzle. Now, who finds that nonce among that competing nodes? They will be the winner, and that particular node will be allowed to create the block. So let us see here. Blockchain, and imagine nonce is 0. What is the hash that comes? This is the hash value. So blockchain, nonce value, that means random number is 0. What is the hash value that is created with the help of SHA-256 algorithm is this hash value. Look at this hash value. Is that contains the initial bits as zeros? Certainly not. So blockchain 1. Blockchain nonce value is 1. No. Like this, blockchain random number 2. Blockchain random number 3. Blockchain random number 4. Like this, so on. Try for all possible numbers. Now, somewhere around. So if you notice, it is around somewhere around, after cross-checking around more than 1 crore numbers of nonces, you are able to find a hash digest having all 6 zeros in the beginning. So whoever is the winning node is the node that identifies that this is the nonce, okay, that gives this particular value. So by what is that solution we have found is the node that found the solution is this is the nonce value. So the node that finds this nonce value is the winner node, okay, and that particular node blocks are added to chain. Okay, so that is how blockchain, when multiple blocks are created, the blocks chains to be added is based on this. So if you notice, to solve this puzzle, it took more than 1 crore guesses. Okay, and whoever is the node that identifies this particular number will be allowed to do this particular hash, otherwise no. Okay, and remember, there is more optimizations to it, and not only proof of work, there are so many other consensus algorithms, proof of stake, and practical Bayesian and fault tolerance, like that. There are so many algorithms using which the blocks are added to the chain. Is it that while doing this activity, is it that conflicts don't arise? Of course, conflicts also arises. Multiple chains may be created, but these would be resolved. Even for that, there are separate techniques for it. So take an example, imagine while doing it, if there are shorter chains are possible to create it. So at that point of time, nodes would accept whatever is the longest chain. This is how conflicts are resolved and proceeded further. And whatever we discussed is about, number one, ledgers, collection of transactions, transactions getting verified, transactions are pooled as the blocks, blocks are getting chained, and remember, we are using Merkle tree data structure for creating the root hash and creating the chains. And whenever you are having multiple blocks are created, proof of work and other consensus algorithms are being deployed for adding the blocks to the chain. There is one more important concept behind the in the blockchain, which is the smart contract. Smart contract is on top of your blockchain, is like collection of code and data. So all of us, we know, while in doing the programming, we understood triggers concept. So that means when there is a particular event, a trigger has to be generated. In the similar manner, you have a code and you have the data. So on a particular satisfaction of a contract period or a contract condition, what happens? That code gets executed on that particular data. That is what is actually a smart contract. Okay, so it can perform certain calculations, store the information, automatically sends the funds to the other accounts. Say, take an example. One typical example is that I took the loan, and every month, first week, say on 10th, I'm paying my loan to the bank. You can think it as a contract. So automatically my account get debited on 10th of every month. So it's a kind of a contract. The smart contract, we are calling it because you are having a collection of code and that gets executed on the data. Okay, again, there also you have verification of the transactions with the help of cryptographic primitives. Now we have understood the fundamentals behind the blockchains, and how do I can categorize the blockchains? I have multiple classifications of blockchain. One is called public blockchain, another one is called private blockchain, hybrid blockchain. So public blockchain, you can think it as an internet kind of a thing, wherein which it is purely a decentralized distributed environment. A private blockchain is meant for a particular company or a particular organization. When multiple organizations are involved, you can think it as a consortium blockchain. And private blockchain and consortium, you can think it as a hybrid blockchain. If you look at the platforms, there are multiple platforms that you can implement the blockchain philosophy, you can, if you are familiar with Node.js, you have a way to implement the blockchain. And you have the platforms such as Ethereum, Fabric, Corda, Ripple, Quorum, Swath, like that. There are multiple blockchain platforms, and it all depends upon what is the type of ledger you want, whether you want a permissionless or whether you want a permissioned, and what type of consensus algorithm that gets deployed over there, and are there any smart contract facility. All that you can see, and you can use these platforms as per your need. And above all that, you need to think whether my problem needs blockchain or not. Now people are now for everything that people talk about blockchain. So this particular diagram gives you a nice illustration. Imagine, do you need a database? Of course, no. If I don't need a database, you need not actually go for blockchain. Imagine that you are having a database, and is it that it requires shared write access? No, my database don't require shared write access. Then you don't require actually a blockchain. Imagine if you require a shared write access. We are not talking about read. We are talking about write. So we are talking about write. The point is that the people who are going to write over your database are trusted or not. If they are trusted, if you are thinking that they are trusted, then you can go about it. If they are not, you need not go for blockchain. If you are not trusted, the nodes which are writing into the database are not trusted, then again you need to think whether I have any third-party tool or a trusted third-party mechanism with which I can handle this trust. Then you actually don't need a blockchain. Imagine I don't need a trusted third party, then I go for whether I have, then only I go for blockchain. Okay, this is where this blockchain comes into picture. So do you need to control the functionality? Yes. Then what type of consensus mechanism that you need to make? Similarly, whether your transactions are to be made public or private, accordingly you choose a public blockchain or a private blockchain. So the point is that you have to check whether actually you require a blockchain or not till this particular point of time. Once you decide yes, after this point of time, yes, you need a blockchain, but what type of blockchain you need is decided here. Okay. So these first few questions are about whether actually you need a blockchain or it is okay, will you go with the databases, typical databases. Once you go through this and come to here, what, yes, you need a blockchain, but what type of blockchain is needed. Okay. So this illustration gives you about it. There are various industry sectors that uses blockchain: financial services, healthcare, public sector, especially land register. Nowadays, almost all state governments are following for land record purpose the blockchain, and similarly energy, technology, almost all sectors. As I've said, wherever the data is there, and wherever the data that has to be shared with the write access, and the nodes which are going to write are not trustable nodes, that's where you are going for blockchain. And the blockchain technology is booming like anything, and almost all sectors, financial, government, as I said, as of now, you can see that about $10 billion of global market size is there, but it is expected that it touches to around $1,593 billion by 2030, okay, which is a massive growth people are expecting to see. So in that regard, there are several job roles in blockchain sector, whether it is a business leader or a blockchain healthcare professional, solution architect, blockchain developer, blockchain data scientist, blockchain administrator. Like that, there are multiple roles. So even those who are really technical or not technical, they can acquire the skills that are needed, and hence there are various jobs that are there, and you can have these particular skills so that you can lead into any one of the job role. So these are all the various references that I have used for collection of this information. Thank you. If there are any questions, I'll be happy to answer.
Thank you, sir. Students, any queries? Any doubts you may ask? Yes. Thank you, sir, for your
Thank you,
valuable
madam.
speech on yes, sir. Valuable speech on exploring blockchain technology. I hope the students you would have benefited from this seminar and gain knowledge about crypto primitives, hashing techniques, blocks, chaining of blocks, and opportunities in this field. So once again, I thank you, sir, for spending your valuable time with us and giving a useful seminar to us, sir. Thank you, sir.
Thank you very much, madam. And once again, I would like to thank Sangeeta madam and others of the Department of Coimbatore Institute of Technology for giving me an opportunity to deliver this talk. And this talk, as I said, is materialized with the help of ACM Computing Machinery. I would like to thank them as well. So in this talk, I have given you the very broad view of blockchain technology and its fundamentals, concepts behind the blockchain technology. I hope that it is useful. Thank you, one and all.
Thank you, sir. Students, you can leave this meet.